Let's try this. So this problem uses De Moivre's theorem. So just to recap, De Moivre's theorem says that if we have a complex number z, of course that's equal to r times cosine of theta plus I sine of theta. That's all here, theta. So if we take a complex number to the n, that's equal to the root radius to the n, cosine n theta, sine n theta. So this is De Moivre's theorem. So if a complex number z1 has an angle 342, and is one of the complex nth roots of the complex non-real number z has no complex nth roots with an imaginary component and a real component greater than the real component of z1. What? Okay. Z is one of the complex nth roots of z2, z1. So z1, sorry, I'll be right back. Okay guys, I'm back. So looking at this, z1 is the root of z2 to some n. z2 to some n. Oh no, z1 to some n if it's the root. Yeah. I don't know. I mean, okay, if this is the root, then this would be like that. The nth root. So z2 to the n equals z1. A complex non-real number z2. Yeah. z2 has no complex nth roots with an imaginary component and a real component greater than the real component of z1. The real component of z1 is z1 is equal to r to the n. No, z1 has the exponent. So z1 is equal to r to the n times cosine of 342 plus r to the n I sine of 342. z2 has no complex nth roots with a negative or imaginary component and a real component greater than the real component of z1. Find the largest possible value of n. So I'm thinking if we have no imaginary component, no negative imaginary component, so that means if you were to draw it in a unit circle, or on a, like draw it on an axis, it's nowhere down here. So all we can be is up here. All we can be is up here. So theta between 0 and pi. So, but like let's say, like, okay, z squared, yeah, that makes sense. But then if you were to take z to the 1/2, that'd be the square root of r, and then so square root of z is equal to square root of r cosine 1/2 theta. But there's going to be multiple roots that are is one of the complex roots. How do we get the others? Cosine of 1/2 theta. So like, let's say theta is 100. Cosine of 1/2 theta would be cosine of 50. Huh. Well, I mean, of course it makes sense that if you have, like, the root of just the normal real number, it will be along this, right? It'll be on this unit circle. Oh no, it won't be on that unit circle, but it'd be on a circle with, like, angles like this. But how do we get all those multiple angles if this is just the Morris theorem? I don't know. If there's no roots with a negative imaginary component, it'd have to be like... There's no complex nth root with a negative imaginary... So, wouldn't sine 342, that'd be negative? $342 is negative, so I is negative. Maybe this is like... This is not... I was thinking of this or, but maybe this is and a real component greater than zi p1. Maybe it's a strict and, but it has to be both. So if it's that, then the real component of z1 is just r to the, or the real component greater than the real component is r n cosine of 342. So, of all the other ones, it can't be past this. So, what is really different? So the real component greater than z1, so it won't be... So 342, so theta can't be between the 342. Can't be between what's 342? It'd be negative 18. So theta is greater than 18. Okay. So theta is between. No, because we know we're saying this is exclusive. So like, we can have negative as long as it isn't in this area. As long as it's not here, then we can have negative. Because then it's not greater than the real component of G1. And it can have, if it's not, yeah, so we just can't have anything here. So theta can't be between. Theta is not in. No, it's not the right symbol. Is not in. It'd just be from negative 18 to 0. So if we look at what 342 is, 342 is, it's like the multiple of, not the multiple, it's the product of 2 and 150, 121, so 171, and then 171 is divisible by 3, and that would go into 18 minus 3, or no, that's not true, 60 minus 57, I think, yeah, it's 57 times. No, 57 is divisible by 3. 3 and 19. 19 is prime. So 2 times 3 squared times 19. So maybe if we can use that because it's n theta, so maybe if it's, oh yeah, I'm gonna say 19 because then it could skip over this. Then I'll skip over this. 19 is my answer. I really don't know though. Oh, where'd my phone go? I'll be right back. I'll go for my phone so I can find the answer. I found my phone. It's just on my chair. Um, 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 I'm sorry that I was $20. Okay, this should be the year. It was 19! It was 19! Since all nth roots of a complex number are 360 over n apart, we need to ensure that 342 plus 360 over n is greater than 360. Okay. So we know we need to ensure that 342 plus 360m is greater than 360, which is, yeah, what we did ensure. It can't be equal because that would mean it's real. Honestly, I don't know if I just got lucky with this or if I just like somehow got it. But yeah, because the answer was, I was kind of thinking this in my head. Because if we had a smaller thing, it'd be here and here, and it can't be there. It must go to here, and then it somehow, because this is negative 18. You can't add 18, that'd be real, so you have to add 19. And then that gives you the answer. So, oh wait, 360 over n. Yeah, I was not thinking that actually. What is 360 over? I don't know. Anyways, thank you guys for watching. See you guys tomorrow. Goodbye.